this session, we will continue to the intermediate level questions on Python loops. Number 1. Write a Python program to find the sum of the digits of an integer. Number 2. Write a Python program to calculate the factorial of a number using a loop. Number 3. Write a Python program to check if a number is a palindrome. Number 4. Write a Python program to count the number of digits in an integer. Number 5. Write a Python program to print all prime numbers between 1 and 50 using loops. First question. In this Python example, we'll write a program to calculate the sum of all the digits in a number. First, we ask the user to enter a number, and we convert that input to an integer. We then create a variable called total and initialize it to 0. Next, we use a while loop that continues as long as the number is greater than 0. Inside the loop, we extract the last digit of the number using num%10 and then add that digit to total. After that, we remove the last digit from the number using integer division num == 10. The loop repeats until all digits are processed. Finally, we print the value of total. So if the input is 1, 2, 3, 4, the output will be 1 + 2 + 3 + 4, which is 10 inches. Second question. Let's learn how to find the factorial of a number using a loop in Python. First, we ask the user to input a number, which we convert to an integer using int_input. Then we create a variable called factorial and set it to 1 because the factorial of 0 is 1 by definition. Now, we use a for loop that starts at 1 and goes up to the number, including it. Inside the loop, we multiply factorial by the loop variable I in each step. This builds up the product step by step, 1 multiplied by 2 multiplied by 3, and so on, until we reach the number. After the loop ends, we simply print the final value of factorial. For example, if the input is 5, the output will be 120 inches. Third question. In this example, we're going to write a Python program to check if a number is a palindrome. A palindrome is a number that reads the same forwards and backwards, for instance, 121 or 1331. First, we ask the user to input a number and store it in the variable num. We also create a copy of this number in a variable called original, because we'll be modifying num in our loop. Next, we initialize a variable called reverse to 0. This will hold the reversed version of the number as we build it. Now comes the loop. We use a while loop that continues running as long as num is greater than 0. Inside the loop, we extract the last digit of num by taking num modulus 10. We then update reverse by multiplying it by 10 and adding the extracted digit, effectively shifting the digits to the left. After processing the digit, we remove it from num by performing integer division, num == 10. This loop repeats until num becomes 0. Once the loop ends, reverse holds the reversed number. Finally, we compare reverse with original. If they are the same, the input number is a palindrome. If not, it isn't. And that's how you can check for a palindromic number using loops in Python. Fourth question. Let's write a Python program to count how many digits are in a given number. First, we take input from the user and convert it into an integer. Then we initialize a counter variable named count and set it to 0. We use a while loop that runs as long as the number is greater than 0. Inside the loop, we remove the last digit of the number using integer division, num == 10. Each time we do that, we increment the count by 1. When the loop finishes, the value of count will tell us how many digits were in the number. For example, if the input is 12,345, the output will be 5 inches. Fifth question. In this Python example, we'll print all prime numbers between 1 and 50 using loops. First, let's recall a prime number is greater than 1 and divisible only by 1 and itself. Examples include 2, 3, 5, 7, and so on. We begin with a for loop that iterates from 2 to 50, since 1 is not a prime. For each number, we assume it's prime by setting a flag variable called isPrime to true. Then we use another for loop to check if this number has any divisors other than 1 and itself. This inner loop goes from 2 up to the square root of the number, which makes the check more efficient. If we find any divisor that divides the number evenly, we set isPrime to false and break the inner loop. After checking if isPrime is still true, that means the number is prime and we print it. This method helps us find all the prime numbers between 1 and 50 effectively using nested loops. We will end this session for today. How many questions did you solve successfully? Comment below, and we will continue this session in next video.